All right, for 44, I'm just going to try to walk you through a little, or 46, I'm sorry. Try to walk you through a little bit, I think, what you need to do. I think that's what you guys have assigned is 46. Oops, sorry, if I'm not mistaken. Yeah, there we go. Okay, so for 46, just walk you through it again. Refer to the real estate data, which report information on the home sold in the Goodyear, Arizona. So basically, that's this information that I have here, that I've downloaded. You guys can find that either at the book site or I've got those data files in the content area. Okay. Use statistical software to compute the mean and the standard deviation of the selling price, and it's important to assume this to be a population. So that's okay. I've done it the old-fashioned way, figured out the mean, which we have to do anyhow, plus or minus, then square that, find the average, and ultimately take the square root of the average of the variance, on and on. Okay, you can do that, but you can also go ahead and use the Microsoft, the Excel standard deviation, but this one's for the population. Okay, then it just says select a sample of 10 homes. So take your pick. I run some random deals here. These will change, okay, if I want them to. Okay, then I would copy. This is how I did it. So random between 1 and 105 because that's how many I had. But these will constantly change if you're putting in some formulas. And so the way I'd get away from that is I'd just take this and I'd copy, say, and then I'd come over here and I'd paste just the values. Okay. Now you can see those changed again, but these stayed the same. Then I took those particular ones that corresponded with the numbers over here. But that's there's other ways to do it. You can start here and take every 10th one. Roughly would fit because I think there's 105 total. However you want to do that's fine, but show your work. Okay, on this particular problem, it's going to be really important that you show me kind of your work and what you did. Okay, compute the mean and the standard deviation of the sample. So again, the mean, is just the average. That's pretty simple. Here's mine, right? Okay, and it's okay to use the standard deviation program, but in this case, because it's a sample, make sure that you use standard deviation.s for the sample. Okay, so I get that, and then lastly it says determine the likelihood of a sample mean this larger or larger from the population. Then we use this formula, right? Okay, and you can see kind of my results there, but they're irrelevant because your sample mean is going to be something completely different. Okay, but again, it's just the x, or that should have the little line over it. I probably wasn't able to do that, right? Meaning that it's the standard mean of the sample minus the mean of the population, okay, divided by, and what do we call that? The standard error of the something or another. Heck, isn't that terrible? The standard error of the mean? Yeah, something like that. The bottom part. Okay, and so you plug that in and you get your z. Okay, you should know, right? If your sample mean is less than the population mean, it's going to be a greater than 50% chance, right? Go back and read the question again. I'm sorry, but it should be greater than a 50% chance. Let's see. Determine the likelihood of a sample mean this large or larger. Right? If your sample mean is bigger than the population mean, then it's going to be less than a 50% chance that it's larger. Okay, so those things should be just kind of obvious and things to keep in mind as you do problem number 46.